Hi, this is your Professor Sudha Kolatu Parambil, section 10.3, constructing confident interval for difference between two means. This is for paired samples. Does drinking a small amount of alcohol reduce reaction time noticeably? 16 volunteers were given a test in which they had to push a button to respond to the appearance of an image on a screen, and they measured their reaction time. And they performed the same test after giving them alcohol, and they made sure their blood alcohol level is up to 0.05%. Now we have two samples of data, one set before the alcohol consumption and the other one after alcohol consumption. These are paired samples because each value in one sample can be paired with the value from the same person in the other sample. The pairs of data are called the matched pairs. So this given table represents the data. So 0% alcohol, this is 0.05% alcohol, and this is the reaction time, and the sample mean of each one is given, and the last row, that is the difference between the reaction time. So if we calculate the mean of this difference, that is same as the difference between the sample means, or we can say that mean of the difference is difference between the sample means. Same relationship hold for the populations also. So if mu d represent the population mean of difference, that is same as the difference between the means. Since population mean of difference mu d is same as the difference between means, the method of computing the confidence interval for mu d is usual method for computing the confidence interval for the population mean. So this is the formula for that. So now let's look at the assumptions. We have two paired random samples. Either the sample size is large, that means greater than 30, or differences between the matched pairs come from a population that is approximately normal. Let's look at some of the notation used in this section. So D bar is the sample mean of the differences between the values in the matched pairs. SD is the sample standard deviation of the differences between the values in the matched pairs, and mu D is the population mean differences for the matched pairs. Here we need to construct a confidence interval for the difference between two means. Here n equals 16, the sample size is small, so we will construct a box plot to check the population is approximately normal. How to construct a box plot? It's on section 3.3, page 139. So please refer that. Here I am going to use TI-84 calculator to find Q1, median, and Q3. And I can use that to calculate the interquartile range and lower outlier boundary and upper outlier boundary. press Stat, Edit, enter all the data from differences into this list L1, and then press Stat, Calc, option 1, and enter. Scroll down, you can see Q1, median, Q3, note that down. Also you can note down the mean and median from here. We can use that if you need that in future for this problem. I'm going to copy down all the information from the calculator. Lower outlier boundary is Q1 minus 1.5 IQR, that is negative 16.5, and upper outlier boundary is Q3 plus 1.5 IQR, that is 27.5. So now we can graph this. So negative 20, negative 10, 0, 10, 20 and 30. We may not need that much. Now because I'm making this looking at these values, negative 16.5 and 27.5, that is the lower and upper outlier boundary. So I will start with these three information. 0, so at 0 put a line, and median 7, so approximately 7 here, and Q3 is 11. Okay, then make a box out of that like that. Okay. Then 16.5, so negative 16.5 is there, 27.5 is close to 30, so that is there. So connect those. So there is no outlier, no strong evidence of skewness, you can see, because there is no value bigger than 27.5 or smaller than negative 16.5, so there is no outliers, and there is no evidence of a strong skewness, so we can actually proceed. I'm going to write down the formula first. So the first step is to compute the sample mean difference, D bar. Step 2, compute the margin of error. So we need to find the critical value. This whole thing is the margin of error. So first we need to find the critical value. N is 16. So number of degrees of freedom is n minus 1, that is 15. Confidence level is 95%. So from table A3 we can find the critical value, that is equal 2.131. This is student T distribution. We will look at 15th row, and alpha over 2 equal 0.025. So we find out this, that is here. Now we need to find the standard error. This is standard error, that is SD over square root of n. So margin of error is product of those two values, like multiply these two. That is equal 5.292. So this is the margin of error. This is the sample mean difference. So add or subtract the margin of error from D bar, you will find the confidence interval. So next step is constructing the confidence interval. So this is 95% confidence interval is so mu t is between these two values. So if you subtract, you will get 1.2 less than mu d less than 11.8. Now interpret the result. We are 95% confident that the mean difference is between 1.2 and 11.8. In particular, the confidence interval does not contain 0 and all the values in the confidence interval are positive. We can fairly certain that the mean reaction time is greater when the blood alcohol level is 0.05%. If you are using TI-84 calculator, use the test T interval. First press Stat, Edit, then enter all the data in the difference. Then press Stat, Test, use the arrow key and select T interval and press enter. We are using the data from list L1 and the confidence level is 95%, so 0.95, then calculate. If you round this value to one decimal place, you can see that is matching with our value. So in this section you learn the assumptions for confidence interval for using matched pairs and how to construct confidence interval with paired samples.